Uh, all right, recording has started. Hello, everybody. Welcome to the
Hey.
URP Shadergraph Introduction. I hope you can all see my screen.
Yeah.
Yes.
Yes.
All right.
Yep.
Warning up front. I am a bit sick, so my voice is fucked, but I will make it work. All right. So our goal for today is we have this very beautiful GIF here. Our goal is mostly to understand how this all works and to remake it. I really want you guys to um, be able to break down your graphics issues and then try your best to recreate pretty much everything you see. Next slide. Robba, why not something cooler? Shut up. I'm talking. Analyze and reverse engineer. Blah 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 blah. All the stuff I just mentioned. So during this session, we will be remaking this GIF, breaking down, do a lot of maths because yes, we do need maths in this. It's very important, and I also really want you guys to tell me what to teach you. Like, preferably this is a bit interactive, and you guys give me like a back and forth, like, oh, how does this work, and then I explain it. But we'll see how far we get there. So first things first, we have this GIF. I want you all to tell me the different effects that you see. So, for example, if I open Unity, this is just like a base Unity, just a regular like cylinder and a cube, right? I want you guys to tell me all of the differences you see between that and this.
Between which ones?
This GIF and like the actual like in Unity. Like, let's say this is the base you guys all start from. Like, what effects need to happen for these to turn into like this?
Okay, so they have, for example, like the base color there, somewhat of a and then their shades are it's like a lava lamp, like a lava lamp shades put on. And then I think the animation effect is something like we just put something separately, kind of, because it's not being like turned around; it just is animating there. I guess it's very on the yellow one. The like the bottom of it is very kind of weird because it's not as all of them. It doesn't have the shade as all of them. It's a bit different. I guess.
And the outlines that change color.
The outlines also that change color. This is also another angle to see. Maybe you can see slightly more what's going on.
Oh, they're filled in. Wow, that's so cool.
Yeah.
Whee!
So let's see what the thing I have noticed. So outline, first thing I would notice, is the solid color, so to speak. It's kind of a modified shadow, but we'll get into that later. The floating bubbles, like the lava lamp stuff you guys mentioned, and the pixelation effect. But I'm not going into that because that's bullshit, and I don't care. All right. So step one is we start up a Unity URP project. Boot it up now because it will take ages. So you go to Unity Hub, Universal 3D. We're using this random pipeline. If you don't have it, install it. Blah blah blah. I technically need to upgrade it, but that's too late. So yeah, I already have my sample project here that I can start with. Anyhow, step two, we are breaking it down. We have all of these effects, so we're gonna write down our own goals, so to speak. So we write down basic tune shadows, because you see in the bottom here, it's like a kind of shadowy effect because it changes depending on like the rotation, right? Outline. floating bubbles, pixelation effect, blah 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 blah. It's very important to remember that in graphics and shader programming, there's a lot of ways to do things. In the end, it's only like the input and the output that matter, and how much like work your PC must do. Like, if you want to turn 1 into 2, you can do +1, you can do times 2, you can do -1,000,000 divided by 500,000, and you all get the same result. But of course, some are easier than the other. And especially for shaders, it is very important to optimize it. A good way to like notice is if you go into your game view, you can press on stats, and this will basically tell you a lot of information, like your frames per second, the amount of batches. I'll explain that stuff in a minute, but it's very important to try to get as optimized as possible. All right, so now let's get to the actual working part. We break it down. Wow, beautiful dancing gives here. Very funny. So, toon shadow. What do we need to make a cartoony shadow?
We need the outline.
Outline? No. We're ignoring the outline for now. We're only going for like the cartoon shadow.
We need a solid color and then the shadow, where the shadow is positioned, like the position of the shadow.
Yes. So we need the position of the shadow. If we work like back, we need the position of the shadow. So we also need the position of the light. Very important. If we have the light source, blah blah blah, do math stuff, check if it's facing in the right direction. Usually, like the easiest way to think about light is if the face is like looking in the light direction, then it's lit. If it's not looking, then it's unlit. Personally, I think that's the easiest way to go about it, but there's a billion different ways, because of course there is. And then apply the colors, blah blah blah. All right, so we want to get started. Our first question, our first big question, anyhow, is lit or unlit. If you go inside of Unity, you will right-click, create shader graph, URP, and then it says lit or unlit shader. Now, there is a big difference between the two. As you can see on this image, also in here. Can anybody tell me what the very obvious difference is?
Left one is lit and right one is unlit.
True. Why?
Why unlit?
Yes.
Or why do you want to use unlit? It's like ignoring the light source?
Yeah. So basically, a lit shader, you have like the standard Unity material, so to speak. If you make a lit shader, I will open it right here. It will basically give you like all the base color, the metallic, the smoothness, the ambient occlusion. It will give you all of those calculations, so you can like do whatever you want with them, right?
Mm-hmm.
Whereas with an unlit shader, it is literally base color. It's just the color. What we want to do is we want to make like our own lighting model, quote unquote. Big word for it, but yeah, we want to make like our own light sources. So it is probably smartest for us to use unlit. Explain this stuff. All right. Yeah. So we go inside of our shader graph. We go inside of our assets folder, create shader graph URP lit shader graph, and we will call it, what was it? Cartoon shadow. Bad naming convention. I'm gonna ignore that for now. So we open up the shader graph, and there's a lot of stuff on the screen. So yeah, you guys just pay attention for now.
It's waiting. It cannot do it that fast, you know.
No worries.
Managed.
I'm just explaining it for now. So we have these things. The top one says vertex, the bottom one says fragment. I accidentally made a lit shader. Fuck. Alright, so I need to make an unlit one.
We need a lit one, right? I think I also made it.
Yeah, unlit shader graph, cartoon shadow. Embarrassing mistake. It's on the recording. Oh well. So we have vertex and fragment. Basically, these are the two outputs. It is very possible to make shaders that do stuff with the vertices. Usually that's done with like compute shaders, but you can do it in Shadergraph too. I will show you an example. Ignore all of the random GIFs on my PC. But if the image will load, yep. All right. For example, the movement of this fish is done entirely through Shadergraph. For example, yes, the movement.
Really?
Mhm.
That's all in the shader.
Yeah, it's all in the shader. It's really good because you don't need to rig, and it's like computationally, it's like less intensive than an entire rig and stuff. But basically, that's done through the vertex. As you see, you have like position here. You can change that through code. I will get back to that later. Normal, which we won't use because it's also pretty much only for the lit one. Blah blah blah. And then we have fragment. Fragment, for example, the base color. This is just what it will display. I will make. So, for example, if we make fragment lime green, so very important first, save asset. And if you want to see your shader, you have to make a material for it. So we're gonna right click, material, cartoon shadow material. And then here in shader, you click on it and go whatever you named the shader graph. So right now our shader graph is just base color lime green, and as you can see, it's working as intended. But of course, it's pretty boring. So what we're gonna do is we're gonna get the blackboard. If you don't see it, you need to enable it here in the right top. I press on.
The difference between vertex and fragment.
So vertex is like the vertex positions of the model.
Okay.
Fragment is it's like a weird explanation for it, but it's basically like the tries that are in between the vertices, like the triangles. There's a really like elaborate explanation of it, but I forgot it. So you're just gonna have to trust me on that. The main important difference between the two is also vertex gets done first, and then fragment gets done. So these two are basically separate. You can't like connect them, quote unquote. Okay. Back to Blackboard. So we have the Blackboard here. This is basically a list of inputs. For example, I can add color. Haha. Let's say cartoon color. I can save. Wait. So we can plug our cartoon color into the output. And now, if we go into our scene, everything's black. That's normal. But we have cartoon color in surface inputs. Now we can set this to whatever we want, and the shader acts accordingly.
Can you repeat it one more time?
Yes. So we have our blackboard. We can add, using the plus, a color. So color, click on that. I named it cartoon color. I connected it to the base color fragment. It's just drag, bloop, save asset. And then, because it's in the blackboard, if you open the material with your cartoon shader shader, it will show up as an input here. So now you can do whatever you want to the color, and the shader will act accordingly.
Oh, okay.
All right, that is very, very basic. Going over the other things, we have the graph inspector. Basically, this has graph settings, which has like a bunch of stuff here. But this is, for example, transparent, which faces are rendered, and a lot of nerd shit that I won't go into for now. Important, if you ever want to switch to another render engine, what you need to do is you have like active targets. You just put HDRP or whatever engine you're using in here instead of Universal, and it will just usually work. Anyhow, doesn't matter. Just ask me when the time arrives. But another thing the graph inspector does is if you click on something, for example, the property of the blackboard of the color, You can set a default. You can set modes, for example, HDR, if you want to get like very cool colors. What do you call them? Like intensity with all of that stuff. Won't use it for now. Doesn't matter. Anyhow, let's set the default to white for now. So there's also the main preview. This just shows like what your material would look like with all of the default stuff. Decently simple. All right, now we have the entire shader graph panel pretty much explained. So now we can actually get to the bread and butter of making our toon shadow. So first things first, we find a light source. Shadergraph is a node-based programming language. If you want to add a node, you click on space, and there's a bunch of nodes here. If you want to get good at shaders, it is very important to know all of these nodes. You just look up shadergraph nodes. There's a decently good video. Yes, 1 hour and 20 minutes. This was homework in Game Art 3 actually. We had to like look at all of the nodes, but this is all like well explained.
Output them in a different
But
folder.
you definitely need to know all of the nodes to know what you're capable of. Anyhow, good video, I recommend. You'll need to watch it eventually anyway. So, we add a node, call it lights. So we have main light direction, which is the main thing we're going to be using here for this cartoon shader. So, right now we have the direction the light comes from, right? So, what do you guys think we need to do now? Think with maths. How do we check if the direction of the normal is facing the light?
I need to get the distance between them, and then, or there was like a math exercise for it, right?
There was.
Yeah, that was cool.
Wasn't it dot product?
Yes, exactly. Good job. So because shaders work on the GPU is pretty stupid. The main thing of the GPU is it doesn't know where any other objects are. So for example, if you're calculating like this exact pixel of lighting, it doesn't know what happens to any of the other pixels. So you can't like check if something else is in front of it. That's ray tracing. It's possible, but there's like a lot of like background stuff. But for now, we have the dot product to just check. So we have our main light direction. We will get our normal vector. Don't worry about these for now. And dot product. All right. So I'm just gonna put this in the output for now. Boop, boop, boop. And let's see. This looks pretty weird, right?
This looks a bit cursed.
It looks very cursed. You have to get used to it in shader programming. Wow, beautiful.
Oh my God.
So
So
shader programming is pretty much one of my favorites because the glitches are just very funny. Anyhow, if we look from here, we can see that the direction facing the light is 0 because that's the way it works. If it's 0, it's black. If it's 1, it's light, right? You can see right now it is doing the opposite. And there's also some very weird glitches going on. So right now we just want to fix it so the light direction is at least the correct way. So I'm just gonna do 1 minus. Bloop bloop. That will probably fix it. Wait, I should have done like times -1. Uh-oh. Hang on.
this haven't fixed it.
Eh?
This didn't fix it.
Yes, but it didn't fix it because I'm silly. All right, we multiply it by -1. That's what I meant to do.
And like if you want us to copy it from you, or kind of like also doing it from you.
You can copy it. I will definitely like I will definitely give you guys the files after. And you can also like look back in the recording. But I prefer that you copy it because you really like learn this stuff through like just testing stuff out on your own, right? Anyway, so right now we have the multiplied by -1, and it is already looking a lot better.
Repeat the multiplied thingy, please.
Huh?
Repeat the oh, okay, so you added one more node. Okay.
I just added the multiply node and I put -1 in the B. Magic number, I know, but shh, nobody needs to see that. Shh. Anyway, if we look at what's her name? Susanna? Suzanne. Suzanne, right. If we look at Suzanne right now, it is kind of working, right? Oh my god.
Oh my god, so good.
So it works so good. But there's a lot of glitches. If you go here, for example, you see what I imagine the Eye of Cthulhu to be like. I'm staring in the void or something. And this, of course, needs to be fixed. So, I told you guys before, 0 is black, 1 is white, right? But because of our dot product, we have like certain places where it is like -5. And then Shadergraph looks at that number and he thinks like, -5, what the hell? And it, huh?
Are you crazy?
Are you crazy? Yeah, exactly. So it clearly doesn't like that, as you can see. So what we're gonna do is we're gonna clamp it. Now, this is a regular clamp node, but it's bad for performance. So we're gonna use the saturate node. The saturate node is just a clamp, but it's between 0 and 1 always. You might think that's pretty niche, but no. Saturate node is all I used. I've never used the clamp node. So we saturate it, so we clamp it between 0 and 1.
So
then
you normalize the values.
Sorry? Yes, it's pretty much normalized. Well, no.
No?
Normalize would be like if I have like mine. How do you say it? Normalize is more for vectors, right? Like
Yeah.
if you have like normalize is just to make all vectors the same length. This is like actually clamping between 0 and 1. All right.
Okay.
But we clamp it between 0 and 1. And look at this. Wow. No more Eye of Cthulhu. Holy moly. And everything. It's so good. And everything works fine and is beautiful. And everything is happy in the world. Right? Okay. So, now that we have that, we can start to move on to the actual colors. Oh, that's a wrong. Apply colors. We are at the third step. Let's see if I have my... All right. So we look back. This is the reference. Very cool colors. So for now, we will open Unity. Boop, boop, boop. We have cartoon color. And let's add another color. Cartoon shadow color. Okay. I think the easiest way to do this, because I'm lazy, is either like comparing if it's, well, it depends. Do you guys want like a smooth transition or like a 1-to-1? Well, I guess our reference is 1-to-1, right? Okay, let's do it smooth transition just to look, I guess.
Or reference is not smooth transition, or
reference is like an immediate transition. But let's do a smooth transition because I'm bored. So
what did you? Okay, so you put a lerp there?
I put a lerp there. I put a lerp with T as the output of the saturate node. So basically, it will lerp from our shadow color to our cartoon color based upon the input of the saturate node.
We grab a beautiful and amazing lerp, right? And what else we get?
Yes, so we grab our beautiful and amazing lerp.
Yeah.
We plug in the chartoon cartoon shadow color into our A. So if it's 0, it will get a shadow color. If it's 1, it will be the regular cartoon color. And then we plug in the output of our saturate node to like see how far it is. Plug that into the fragment. Bloop, bloop, bloop. And wow! Then we can go to our cartoon shadow color. Put it like color theory. Wow! And then you can make your own very amazing colors. All right.
Wow, that's so cool.
So this looks pretty all right.
So for like these inputs, how they work, right? The A is like if 0, and
Yes.
B is if
The-
1.
It's just like the regular lerp, regular lerp in C#, where A is 0, the second one is 1, and then the T is just depending whatever, right? Okay, so this looks pretty good, but our reference is basically like a very hard transition. So the lerp is wrong. We can. What we can just do is we can put a comparison. So we create node comparison, and we compare input A, and if it's greater or equal than 0.5, we will output it. Oh, right, it does that. It's just 0. What? Hang on. Okay. Sometimes you will get it like that the values are really shit. What I typically just do is I make a float, and I make that you can fuck with it in the material itself. So we can call our float threshold. Bloop bloop bloop. Plug it into this. Save it. And then when we go back into the scene, we can fuck with our. Oh wait, we can fuck with our threshold. And yeah, that looks alright. It's a bit weird. But now you can like manually change it.
Oh, okay. So basically, what you do, like you make this like variables kind of, and then you just plug them, and then you will see them directly
Yeah.
on your.
Then you will see them in your material, and you can directly change it.
In there. Okay.
All right. But this is like right now it's just like a boring number, which is really annoying to work with. What you can do is you can click on threshold, and in graph inspector, you can go slider from 0 to 1, save, and now it's a beautiful slider. Wow, that's way more nice to work with. All right. So this is all pretty well and good. It looks all right. It looks a bit weird. Sorry?
Can you show one more time the slider thingy?
Yes. You just click on the thing in the blackboard, and then on the right in the graph inspector, you can set the mode to slider.
Okay.
This doesn't matter. Blah blah blah. Nerd shit. And then you can, in the material, use the slider. Wow. All right. So let's set it to 0.25. That's a nice round number. All right, and now it will still work. Wow. Okay. Anyhow, our next step. Oh, I keep opening this one. Our next step is the lava lamp effect. So this is where it starts getting interesting. With interesting, I mean complicated. We're gonna introduce a very influential player in the shadergraph scene, noise. All right. So there's a lot of different noises. I'm gonna pop them all up here.
Is it like gradient noise, simple noise? Which noise have you used?
Yes. Right now I'm just gonna pop them all up to show them off.
Okay. Sure.
All right. So we have 3 different kinds of noise here. We have gradient noise, which is I don't know how to describe it. It's like a rash or something, right? It looks a bit ugly, I'll be honest. You have the simple noise, which is just like every pixel is a random number. This is pretty much the classic. And we have Voronoi noise, which is kind of like these cells, right? If we go back to our reference, all right, you already have to have like an eye for this, but in here you can see like the more lava lampy ones, they're kind of like cells, right? Or like circles.
Like
Hmm?
circles. Okay, yeah.
Yeah,
Circles stick to each other.
yeah, you can kind of see it, like, right, and they like fuse into each other.
Yeah.
This is pretty much exactly what Voronoi noise is. Like if I play with the angle offset here, it's just like the random value. Oh, this is it at 0. But you can see like these little like cell kind of things like moving and bobbing together. It's pretty obvious that for here it's like Voronoi getting used. So what we're gonna do is since we want, well, all right, so I'll do output ploop ploop multiply node. It is very nice to be able to control these things like on yourself. So we're gonna use noise strength, and we're gonna add a slider again. Bloop, bloop.
Noise strength is a float. Okay.
Yes. Float noise strength, and it's probably going to be easiest if we just add it in right after our multiply node. So add bloop bloop, because then it already is taking advantage of the saturate.
One more time, what you did now?
So I added the multiplied Voronoi noise right before the saturate node, because that way I don't have to saturate it again. Otherwise I have to clamp it again, because it will be above 1.
Why? 1 second. Don't run too fast, please. Me is not me. Okay, why have you connected this one to B and the other one to A?
It doesn't matter. It's adding doesn't matter. I'm just silly.
I'm just asking, sometimes it matters a lot.
Sometimes it does matter.
So,
but not.
How clean has your how clean do you believe the shader graphs should be?
It really depends. Hang on, I can show you guys the answer key. This is what my shader graph looked like for the noise thingy. It's not very clean, but the thing is, I know what's going on in there. But you can definitely like make it very clean, especially if you like use Ctrl G. Then you will like make a group, and then you can like label stuff, and it's very nice. For example, light directions.
Weird.
Or Ctrl G noise. You can also right click and create sticky notes. And then you can like write stuff. This is basically the shader graph for comments. So new note, noise. This is where we handle the noise. You can use sticky notes as comments. For example, right? Okay. So let's go back.
Oh, yeah.
Are you up to date, Anita?
Yeah.
All right. So let's go back. We have our noise strength, and let's add some. Okay.
Oh wow, the cylinder looks cool.
Yes, it looks very weird, right? We have a problem right now, which is that it isn't animated. This is very easy to fix because of this angle offset. This angle offset is like basically the randomness influence. We can just plug that directly into a time node. And Like right now inside of the thingy, you can watch it move. Very nice. This is because of the time node. I'm also going to include a noise speed, and then just multiply that by the time. Blah blah blah. I just think it's nice to have control over most of these things. Boop.
A bit slower. Like, okay, not one more time. Give me time to just fill it in.
Yes. No worries.
Because it's kind of fast, and I need to clean it up so that I see it. Scroll to the time in this thingy where you have it. Okay, so use noise strength, not noise speed. Okay, it's already noise speed.
Yep.
All right. Sure.
So if we go back, our noise speed is currently 1, and you can see the lava lamp effect, right? If we want to set it faster, we can set it faster. Wow, very fast lava lamp. If we set it slower, we can do that. But for now, 1 is good. And we can play with the strength even more if we want to. On more complex models, this looks a bit weird, but
This fucked, yeah.
yeah. It also just works better on like soft edges. Like for example, for this cube, it looks very weird because if I like rotate it enough, it will also like become the orbs, right? Like this looks like boba balls, not like a cool effect. Like it works way better on the rounded edges. But that's not my problem. Okay, so we have most of it.
With the shader one more time, I couldn't multiply this for an thingy. Okay, time to add this to be you. And then this thing, okay, it goes to the angle offset. Why is it angle offset?
It's just the fucking thing they use for like the randomness. We can also fuck with the cell density if we want to. You could make that another property, but I am lazy for now. But like for the other noises, they work based on UV. I will explain that in... Well, actually no, let's do it now. Because as you can see here, this one doesn't follow like the Orby blobby one. This one is actually based on a different kind of noise. So what we're gonna do is we're gonna make a Boolean. I think Boolean is the best part, yeah. So we're gonna make a Boolean using Voronoi. Haha, get it? Because I Voronoi noise, get it? Haha. Anyway. We can drag that in. And basically, if we look inside of the material right now, it's basically just like a check mark. Like the Boolean is just a check mark. It's very easy to use. So basically, this is how we're going to use if statements. We will plug this into a branch node, which is basically the shader graph equivalent for an if statement. I don't know why they named it branch. I don't know why it's named predicate, but that's above my payroll. So we can plug this in. Also here, the true is 1, the false is 0. That's basically the standard for everything in Shadergraph. And I'll go deeper on that later. There's just a lot to talk about. But using Voronoi, so we plug the output of it in here. Boop, boop. I'm just replacing it with this branch node. And we want to use a different kind of noise, right? So, somebody pick between gradient or simple noise for me.
Gradient, yeah.
Gradient? Alright, thank God. Simple noise looks very bad. So, For gradient noise, we only have two things. We have scale, which you can see here, and you have UV. So we obviously can't like change anything else to like make the noise make more sense through scale. So we have to do it through the UV. So don't copy for now. I'm just explaining something. So UV is also very much used in the shadergraph, and it's very important to understand. But you know, every 3D model has like a UV unwrap.
Yeah.
Same thing in shadergraph. So what I have here is a UV node. Basically, the left bottom is 0, 0, and instead the X, Y coordinates of the UV are like R and G. So you have colors. Colors are RGB, right? They basically, like, if you have a vector node, if you have like a vector tree, then it's basically RGB. They just make the XYZ and the RGB the same, right? So here you have like a 2D plane, so to speak. And it's kind of like a, I don't know how to call it, like a map. Ooh, that's not what I meant to do. It's kind of like a map. So here is 0, 0. If you plug that into this, you have 0, 0, 0, which is black. If you go to here, you are at, hang on, 1, 0. So 1, 0, 0 is red 255, green 0, blue 0, which is red, right? Same for Y. If you go up Y, here you are 0, 255, 0, so green. And then if you mix them, you get yellow. Do you guys understand this? Okay. No. It's very important for you guys to understand. X, Y, map. Hey. So you have like this, the X axis and the Y axis, right?
Yes.
This is just like a random example. In here, X is 7, Y is 4, right? Everybody knows that.
Yeah, sure.
Basically, what Shadergraph does is to make it like visual. They basically say, well, colors are RGB. Hang on. So if I go into colors, you have R, boop boop, G, boop boop, B. To make it visual, what they say is like the X coordinates is our red. So basically, the more X you go, the more red you are, right? You can see this here. So X, red, X0 is black. So if we go on the color wheel, we go more right, we have more red. We have the same for the Y. So 0, 0 is black. But if you go up in the Y, you go up in the green. And it becomes green. If you go into the right top, you are both very red, both very green. So you get yellow. Do you guys get it now, question mark?
Yeah.
Okay, good. So,
With blue. Will you do with blue in this life, or there is no blue? No blue exists?
sorry?
The
UV
blue
has no third dimension.
UV has no third dimension because it's a 2D thing, right?
We can't have blue?
If we have blue, it's basically like in 3 dimensions. Actually, this is a really good opportunity for me to show you guys. Position, world, I can plug this in. The thing is, Shadergraph thinks that XYZ coordinates and RGB colors are the same. They regard it as the exact same thing. So, hang on. It looks a bit fucked now because it's like more than 1. Let's divide it by. Let's divide it by like 100. Don't copy this. It's gibberish for me to show you guys. All right, so we have divided by 100. So if you move it more here, we get more red, right? I don't know what's glitching out like that. What the fuck? Hello? View absolute world. No, that's not it. Alright, but yeah. Here, the x coordinate is oh, I'm going minus. That's why. I'm stupid. So the more here you go, the more red you go, right? Wow. And then you can go up for more blue. And then here it's almost white. Then we take the green away. And basically, you can kind of like visually see, right? If... Okay, fuck it. Hang on. Poo, poo, poo. All right, you can kind of like visually see the red moving away, right? No?
Yep.
All right. Now you can see me adding more blue. Wow. This looks
cool.
It looks cool, right? And now I can move all of the cubes up to add more green. Oh. But okay, that's what I meant with like XYZ coordinates, and colors are basically the same. They treat it as the same. Because it's just like three different, how do you call it? It's just three different floats, and that's the important part for Unity. Okay. I think my tangent is... I've gone on enough of a tangent. Let me add my cube back in. Okay. So, I hope everybody understands that. It will get even more fucked now. So,
we have UV.
We have UV and we have our gradient noise, right? I'm just gonna duplicate the noise strength thingy that we made before. Yep. Plug it into our branch for false. Okay. And we can see right now we have the noise, right? This is what the gradient noise looks like. Pretty fucked. But we also want this to move. So we have the UV. This is gonna get annoying and weird, but I will try my best to explain it. Basically, there are a lot of things you can do with UVs.
Robert, stop.
Oh.
Stop. Show again.
Yes, sorry.
The UV? Oh. No, the branch connection. One more time. Is there difference like the true false? No difference, right?
No. Well, for here it is because the true if using Voronoi noise is true, then it's gonna use the true path, right?
Oh, okay, sure.
It's just so you don't fuck up the paths, mostly. That's important.
Yeah.
All right. So we have our gradient noise. The only way to move the noise around is to fuck with our UV channel. So, I think it's called rotate. No. Well, what we can do is rotate it. I will plug my time node into rotation. And now it's like constantly spinning. You see? There's basically a shit ton of like different... You can see it's rotating on here too. But there's a shitload of UV operations you can do. Swizzle is also a fun one. And I think it's the right node. I hope it's the right node. No, swoosh? Fuck, what is it called? Hang on. I'll be mad until I find it. Ignore this. Okay, whatever. I should be teaching. Oops. Anyhow, back to this. Let's ignore this fill node. It's probably Swizzle or something. But there's also a move. What's it called? Transform? No. I will need to look it up. Sorry. What did I use for it? Not this one. Wait, what? Oh! Okay, apparently it was... I didn't use it. I still need to show it off. Fuck. Sorry, guys. Technical difficulties. My mind is not cooperating. Oh, wait, here it is. Tiling and offset. Yes. Yes. So we're gonna... This is basically like a UV. Just like a standard UV. But there's like a lot of things you can do with it. So you can make a tile, of course. It doesn't show because it's stupid, but trust me, it's tiling. And then the gradient noise tiles too. You can move the offsets, blah, blah, blah. What we're gonna do is we're gonna plug our time node with multiply into our offsets, and then it will move around.
One more time. I get somewhere lost.
Yes, so we have our tiling and offset.
Tiling and offset, yes. And we put it to gradient
to gradient
output into the UV of the gradient noise.
One
And the offset is based upon the output of the multiplied time node. Lots of words, I know.
Can you show the time multiplied one more?
It's just the same as a Voronoi.
Do we copy it or?
You can do whatever. It's all the same in the end.
Or we use just the same one?
You can. I use the same one, but you can do whatever. If we
get to the last one, okay. Offset in the offset to the offset. Okay.
It was twirl. Okay, but if we look inside of our scene right now, it's not pretty because it's going way too fast. But like you can see the effect happening here too, right? I think it looks pretty cool. If you want, you can make it like move differently on the X and Y axis, so you have a cooler effect. I don't care enough. And the Voronoi noise looks prettier anyway, so I'm just gonna use that for now. Okay. So this is our cartoon thingy sorted. Woo! We have the toon shadow. It only took us an hour.
Yay.
All right. Oh, we also have the floating bubbles. We can actually like cross that out too. Oops. I don't know why I did it here. Okay, so we have the cartoon outline. So we're gonna do the outline now. So you guys remember the outline? I'll show the image again. Whoop. These are the images. Look very clearly at the outline. Very pretty, right? Oh, y'all go, oh, come on. Yeah, there you go. All right, audience participation. So let's break the effect down. What do you guys think we need for the outline? What's our first step?
For the outline?
Yes.
I mean, it sometimes done like the copy of the object you have and then like the backface of it or something like this. I don't know. Like it's somehow because you need to like see the outlines always kind of from the outside. So you need just like the second skin of an object and then to see the under of it.
I understand what you mean. And that is a way to do it. This don't look at this. Like you mean like make a second object that has like the back face, right?
Yeah.
Yes. This is the hang on. Ignore all of the highly complicated.
There's a
bullshit.
plane going by, sorry.
Oh, don't worry, we don't hear it. But this is what it would look like if we do what you mean. No, we're going to do it differently, possibly worse, depending on what you need.
Is there also a way to do it like in Substance Painter where you can like specifically check for the edges
Well,
or something?
not really. Well, yeah, kind of. There is a way to do it in Substance Painter, but I am going
No,
to.
I mean the same way. I mean, like in Substance Painter.
Oh.
Like you can generate an edge map and like it uses that.
You guys are making it too complicated for yourself. Hang on, I'm opening the door. It's very
It's
warm
just
in my
like
room.
light, but very, very intense light. I don't know, maybe I'm on the edges somewhere.
Okay. I am going to show you guys how to do post-processing effects. So, you guys are all thinking about like the object itself, right? Like right now you're thinking about like, oh, shaders applying to the object. We're gonna do something entirely different and also complicated, but I really want to show it off because it can be very useful. So we will be making a post-processing effect. I will quickly make a basic one. So Shadergraph URP, which one is it? Full screen Shadergraph. I will click on it. Post. Post.
Can you repeat one more time what you opened?
Yes. Create Shadergraph URP full screen Shadergraph.
Okay, so create Shadergraph URP full screen Shadergraph. Okay.
Yeah.
What do we name him?
I named it just post-processing. So we have this base color and alpha, no vertex because there's no vertices involved.
Amazing.
Amazing, beautiful. We make a material because this also works in materials. Call it post-processing material. Same thing as before. You go to the shader, just do the name of the shader. Now, so according to our thingy, we should only be seeing gray if the post-processing works, right? Because the alpha is 1, base color is gray.
Yep.
Do you guys see gray?
No.
No. Okay. If you want the post-processing effect to work, then you need to go to your URP settings. So in normal URP, it will have made like a little folder called settings. You click on that. These are like all different kinds of things that Unity uses. Oh, that's where the ambient occlusion came from. Haha. Okay. Usually, if you're in editor, Unity will always like use the highest one, so like the highest quality one, right? So you go to URP high fidelity renderer asset, which is this one for me. Okay.
Okay.
Okay. This basically controls how Unity is rendering your entire scene. We're gonna do something. We're gonna click on Add Renderer Feature. Now.
I don't have the same thingy. I don't know where you.
Then you probably clicked on the wrong one. You have URP high fidelity and URP high fidelity renderer, and you need a renderer.
Okay, where you go? High fidelity render.
Yes.
Okay.
All right. We click on Add Renderer Feature. There's a couple things here. I'm gonna do render objects for now to see if I can make it work because it looks cool. Make a new layer. I'm just experimenting, but I'm just showing off what you can do with it. Render layer. Don't copy me. It will probably not work anyway. Okay. It didn't work. Nope, it still didn't work. Okay, never mind. Let's delete this. But that is like a way to like render certain objects on top of each other. For example, if you wanted to see this like through the other things, it would be a way, but it's very weird to do it. So add renderer feature. We're gonna go full screen pass renderer feature. Okay. If you click on that, your entire screen will fucking look like God came down and like tried to flashbang you, right? This because for some reason Unity made the default for this an invert colors, and it's very annoying. But you have a couple things here. You have the name. I will call it outlines. Oop. You have the injection point. This is basically when your shader will apply. So if you have the renderer pipeline, hang on, let me bust open Paint to make a very good explanation of everything. Trust me, guys. Give me 1 second to connect my tablet. Okay. So in Unity, basically, the way that rendering objects works is it's done in basic steps, right? There are like 3 important ones. You have the opaques. Basically, Unity renders everything that is like not transparent first. Only then it renders it transparent. Transparency. Yeah, my handwriting shit, I know. And then it does like the post-processing. Basically, injection point is telling you where it will apply the shader. So, if I have, for example, a sphere. Let me turn this off since it's annoying. If I have a sphere, let's say, I make a material for it, transparent. The main important thing is that it's transparent. All right. So this is a sphere that is marked as transparent. It has 100% alpha, so it isn't transparent, but it's still marked as transparent. And because of that, if we enable our post-processing and we put it before rendering transparent, this will not be applied, right? This is only important for very minor glitches, and it can be very annoying, but it's very useful to know. Okay, moving on. Sorry. We have the pass material. Sorry, did you have a question? No?
What?
Okay. Don't worry.
You have. I get a bit lost.
Yeah, it's all nerd talk anyway. It's only for like minor glitches.
Right, I was just what?
Okay, don't worry, it's not that important. But now it is. We have pass material. For pass material, what you want to do is you want to grab your post-processing material and you want to drag it in there. And everything's great.
We're grabbing post-processing material. Where do we grab it?
Okay, the material made. Everything is great, as you can see. Woo! We did it! Finally, our post-processing material actually works. So we can do the same thing as before. We can make a float with like alpha. Bloop, bloop, bloop. Make it a slider. And now we can control the alpha of our post-processing material. Oh, wait, what? Huh? Did I fuck something up?
So it became.
Sorry.
It became gray, and then what?
I added a slider float value for alpha. But right now it's not working. Oh. Okay, I figured out what happened. So right now the alpha doesn't work. This is because shaders are annoying sometimes. You want to go to graph settings. and you want to go to blend mode. Basically, this blend mode is like how it works with the alpha and the stuff. I don't know why it's not on by default, but now it does work. All right. This is possible to happen for regular objects too, that the alpha value or the opacity just doesn't do anything. And then you go to graph settings, blend mode, and adjust. Okay. So now, after all that, we have basically gray shutters that we can put over our game. Very cool, I know. But this is not how we're gonna make any outlines whatsoever.
Maybe show one more time when you took the URP. Have you put there something also? The high fidelity something?
I just put the post-processing material.
Material there, okay.
Otherwise, it shouldn't matter. Okay. What we can do now is we can do actual cool stuff. I will go into sample buffer, it's called. URP sample buffer. This is what it looks like. And it looks very weird, I know. But if we connect it to the output, then you will see what it is. So right now it's set to normal world space. If we make alpha 1. Basically, this shows all of the normals, right?
Oh, wow.
Yeah, it looks very cool. I really like the aesthetic of it. But our post-processing just takes every normal and then it shows. We can also put it to motion vectors, which will probably not show us anything. But if we move an object, never mind. Oh, wait, it's only when it moves in game with physics. Whoops. Okay. Just keep that in mind. But motion vector should be like when it moves in game. I thought it would work, but apparently not. Then we also have blitz source. Alright, blitz source is literally just the color after processing. So right now, nothing changes because it's just taking the exact same image. If we want to make something, for example, a black and white, you guys remember that it's like RGB? Every gray just means all of the RGB, the R, G, and B values are the same. So what we can do is we can normalize, bloop bloop. I think this will work, I'm not sure. Oh, it won't, never mind. What we can do is we can split. So right now we are getting our RGB colors separately. We can add up all of our RGB values. And, sorry, there's a plane going over. I hope you guys can hear that. Okay, but what we did right now is we added all of our RGB values. We can divide that by 3. Oh, if it will work. Yep. And then we can, what's it called? Compose. XYZ vector 3. There we go. And then we can get a vector 3 node. Put this all up. Basically, what it does right now is it takes all the RGB values, it adds them, it divides them, and just makes them the same. What we've essentially made is we've made a grayscale slider. So using this, you can make like some pretty cool grayscale stuff, or do some cool color effects. Maybe I want grayscale, but I don't want red to be involved for some reason, because I love red, it's my favorite color. Then I can do this, boop boop, and oh, I think I fucked up. Okay, I accidentally made another effect than what I was hoping for. Oh well. It looks kind of cool. I'm not gonna complain.
You should get the where does your alpha still stays at alpha, right?
Yes. Right now I'm just showing off like kind of what you can do with all of this. Oh, also very important to note. If I go UV, I just connected the base color to a UV node. This is pretty much what you will get. It's just a different kind, but it just shows a UV map of like the screen position, right? Okay, so now we can get to actually thinking about our post-processing effect. So we want to break it down again. Since we have a post-processing effect, we don't know about the objects. So what is the first thing we will need to do?
For what? For the outline?
Yes, for the outline.
Oh, we still haven't gotten to the outline.
Yeah. We're still building up to it. Mm-hmm.
Yeah, I think this always like for the outline.
For the outline, yeah.
Like no outline. Oh, sure.
All right.
Okay.
So for the outline, what do you need to find? Most importantly.
The object.
Yes, the object is what we need to find. But
Like the radius?
The outline of the object.
yes.
No.
Yeah, actually, yeah.
The silhouette of the I don't know.
It's just edges is what I meant.
Just, yeah.
All right. So we find the edges, and then I think we just color it, right? Yeah, color edge. Blah blah blah, and then post processing, whatever. I don't think I have anything else on this PowerPoint. Oh, I have exercises. Okay. So we need to. This is a wrong Unity project. We need to find the edges. So right now we have the sample buffer. How do you guys think we will find an edge in here? Okay, for example, I'm opening.
The primitive shape.
Hmm?
Because Unity has like a limited amount of primitive shapes. Can you kind of give that reference to the buffer?
Primitive
Instead
shape?
of working with a cylinder or a sphere or a cube?
I'm not sure what you mean.
I thought that maybe you could give like the reference of the shape you're using, the object you're using.
Oh.
To the buffer.
Maybe that's a way to do it, but I think there's a simpler way to do it.
Okay.
Right now, if we imagine ourselves to be the post-processing shader, basically what we get is like the output, right? This is the only thing we know. We only know like the colors or like the normals, right? So what we want to do is we want to like zoom down to per pixel level. So right now we are this pixel. This pixel. Hello. Oh, I didn't have it set to red. Right now we are this red pixel here. So
Okay.
we want to find out if we are an edge, right? So what I would do personally is I would look to my left. They are also a black pixel, so that's not an edge. I would look to my right. They are also a black pixel. They are not an edge. I would look above, black pixel, blah, 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 right? And then when it is an edge, how do you figure out that it's an edge? Like, you can find both of the colors. Like, you can find both black and you can find both white. But how would you know it's an edge?
It's not a face.
Isn't that like a depth map?
We can get to depth later.
Okay, sorry.
But no. Depth map is like a way to do it. But I'm just asking a simple question. How do you know How do you know the color is not the same?
Change in value?
Yeah, you just compare them. That's pretty much the only thing we're gonna be doing. We're just gonna look at the pixel next to it. We're gonna compare if the color is like more than a certain threshold difference, then we will do whatever, right? So I don't feel like writing it all out, but I guess I'll have to. This is the finish shader. Basically, yeah. I know it looks like a lot, but it's very simple. We just get the URP sample buffer. We like add 1 to the screen position, or subtract 1, and if it's higher than a certain threshold, then we just color it in the end. How the fuck am I gonna explain all of this? Hang on.
It's all for the outlines.
This is all for the outlines. Well, it's more like this is the outline.
Completely all, or only this. Okay.
This is
Only that.
this only is for the outlines, but it's only for the normals. Basically, I do it for like every map. So this is the outline for the normals. This is the outline for the color. This is the outline for the scene depth. So basically, like how deep it goes, so to speak.
But there are like a lot of components which you kind of like look the same at least.
Yes, it is literally copy pasted outside of the URP sample buffer one. This is like regular URP sample buffer. This is URP sample buffer with blood source, which is the color.
Can you somehow like change the nodes, like grab the node itself and say, okay, you're gonna be a different node?
What do you mean?
I don't know, maybe can you just like grab the node and then say that this you're gonna be different? It's just a question about nodes.
Instead of creating it from scratch?
Yeah, like just change it.
Not really. You just have to delete and go over it. Okay. So
We create a new one. 1 second. Shadergraph unlit.
no, we're still in the post-processing one.
We're still in the post processing. Okay.
Yes. Now we're gonna do the actual outline. I'm only gonna do one outline, but the rest are pretty fucking easy. So if you have this one, it's just like changing the URP sample buffer. Okay, so first things first. What we do is we get the screen position, right? We need a screen position and a URP sample buffer. Okay. So if we want to compare this to its neighbor, then we need to add 1 to the screen position and also get a URP sample buffer there, right?
A bit slower, please.
Yes. Let's do color.
So screen position and URP sample buffer and
Blood source.
URP.
Yes.
Okay.
What the fuck are these? Oh, I forgot. I'm not gonna explain that. I don't know it myself. Okay. I mean, maybe if I... Hang on, I'm just checking something. Maybe I can make it simpler for you guys. Never mind. I don't know what the fuck is going on. Okay. So we have our screen position at default and our URP sample buffer. I'm gonna peek here because I already did it before and I don't want to do it again. Okay. I'm gonna copy this. So what we're gonna grab is we're gonna grab a screen node. The screen node just gives us the width and height of the screen, right? So we're gonna put that in our vector2. So right now we have a vector2 with the size of the screen. We're gonna divide 1 by the screen size. This is basically, we're dividing 1 by the screen size because our UV right now is 0 to 1, right? It's a 0 to 1, but it just like stretches, so to speak. So if we want to go 1 pixel to the left, we have to go like 1 divided by the screen size. I don't know if this makes sense. This is the part where you guys tell me if I look crazy or not.
A bit.
Okay. Hang on. Right now we have our UV. And my paint doesn't work. Fuck. Right now we have our beautiful UV square, right? So our screen our screen, it says like the left bottom of the screen is 0, 0. The right bottom is 1, 0, blah, blah, blah. Basically, we just have the UV map, and the UV map is just like extended upon the entire screen. Yes?
Yeah, sure.
Yeah. Okay. So if we want to move 1 pixel to the left, we can't go -1 because then it will be a screen over, so to speak. What we need to do is we find the screen size, and we just calculate how close the next pixel over is, which is what we do here. This is like what we essentially have here is like we calculate the size of a single pixel on our UV map, right? So if we want to move 1 pixel over, we can just add or subtract it. Yes?
So we 1 second.
I can move this.
Can I type today?
Hmm?
My laptop decided that his keyboard is not working. It glitched. No, it doesn't. But no, not working. What? Yeah, not working. Cool. Yeah, we can go further, maybe.
Okay. The important part is we calculate the size of a single pixel. We do that so we can go 1 single pixel to the left or 1 single pixel to the right, right? So if we have screen position, we can add, hang on. If we want to go a single pixel to the left, so we split it into only the X, and we add it. So right now we have our screen position. This one gives the regular pixel. This one adds 1 to the right. So this is the pixel to the right, right?
No, slower.
Slower? Okay.
Slow down.
We calculate the size of a singular pixel. Yes?
Yes.
We want to compare the pixel to the pixel around them. Yeah?
Which one do you use? Zoom in a bit? Split? No,
Split.
so this is screen position, and then okay, this is the add button. Okay, and it just like displays like this.
Mm-hmm.
Okay.
The split node, I have it here, so it only like moves 1 to the left, because right now we have the size of the entire pixel. So if we would add it, it would go like 1 to the top right. We only want to go 1 to the right, so we do just a split node. It's only like the width of a single pixel that it goes, that gets added, and then we get the pixel here. Are you with me?
Okay, so split, then we add it.
Split, then we add it. Yes.
There.
All right. So now we have a pixel, and we have a pixel to the right. Yes? What we can do for now is we can do a comparison node, and we can set it to not equal. And we can set it to the output of our fragment. So what this will do is we have our pixel, we have the pixel to the right, and if they're not the exact same color, then it will be white. If they are the exact same color, then they will be black. So let's see how horrible this looks.
Which
All right.
is buffer? Oh,
sorry?
Wow.
Very
yeah.
weird effect, right? I will disable this because it's fucking with my things a bit. Oh my goodness gracious.
This is so cool.
Okay. I'm taking the thing I said about like Shadergraph oopsies being the coolest is very true. All right. Okay, I'm still tripping a bit, but whatever. Right now, we can see, wow, our edge is detected, guys. We did it! We detected a singular edge. And also a lot of oopsies. But that's okay. If we want to like up it a bit, we want to be. So we basically want to look how much the difference is between the two, so we don't get all these like random ones, right? So like, sorry, let me. So the difference between this pixel and the one to the right is barely anything, but it's still not 0, right? And that's why this entire thing is white. What we want to do is we only want to see if the difference is like big enough, right? So what we're gonna do is how did I do this? I forgot. Subtract and length. Okay, I get what I did. We subtract, we subtract both of them, and then we look at how much is subtracted. So we look at the difference. So length is the same as absolute value in this case. So for example, if there's a black pixel and there's a white pixel, then an entire 1 will be subtracted, right? But if it's like a black pixel and a slightly blackish gray pixel, then the length will be less. So we put this into our comparison, blah, blah, blah. If it's more than a certain threshold, which we will now make threshold, we will also make this a slider. So if the difference is bigger than a certain threshold, then it will be white. So we put our alpha up. Right now the threshold is 0 and it looks weird as fuck. But if we up our threshold, wow!
Oh, we actually have edges.
We actually have edges. Right now, the edges look very weird because it only is looking to the pixel to the right. So this is why this looks so weird. We have like a dotted line. That's just the anti-aliasing. Like if we go here, then it's fine, right? But it doesn't work vertically. So what we're gonna do is we're gonna do the exact same thing, but vertically. What am I gonna do to add these together? I'm thinking. Comparison greater than threshold. We're gonna add, and we're gonna. What was it called? Fuck, saturates. So we copy this entire thing.
Can we pause for 1 minute? I need to plug my laptop.
Yes.
Thank you.
We plug the entire thing in, and we do green instead of red, so it's Y instead of X. Actually, I was gonna take a break soon anyway because I really need to pee. All right, let's say we do a 5-minute break, or wait, let's do 15 minutes.
Nice. Let's do.
All right.
Salad break, tea break, whatever break.
Tea break.
Don't break.
What?
Don't break.
Don't break in your break.
Okay. I will stop the recording. Please remind me to start it again. Wait, no. If I stop the recording now, then I'll have to edit it together. That's so much effort. Okay.
You can pause it in OBS, right?
Huh?
You can pause it in OBS. Like it
Oh, you
pauses
can pause
just
it.
adds it to the
Yeah.
recording.
Okay. I have paused recording. Is everybody here?
Yep. Or at least I am.
We're back.
All right.
You're
I completely forgot where we were. But for the people watching the recording, you are now like 15 minutes into the future. All right. look at our scene. So, I don't know if you followed this, Anita, but I did the exact same thing, but I replaced the R with G here. So it uses the Y coordinate instead of the X coordinate.
Why?
Yes.
Repeat again. It's like the second. You duplicated it. What?
So I duplicated all of this.
Okay, so you took the ones which we had already.
I took the ones which we had already. Control C, Control V, and the only thing I changed was I made it a G here instead of an R. So
What are the nodes you use to connect these two?
sorry.
The
Oh,
nodes you use to
yeah,
connect
yeah.
these two.
So I just added an add thingy and a saturate node.
Oh, okay.
So it just adds them and it gets above 1, so I saturated it.
So so the comparison stays, right? And then we duplicate this whole together.
Yes.
And then add node and set to rate node.
Mm-hmm. All right, I'm gonna.
Can we do it? Leave it. 1 second. I cannot do it this fast.
It's okay.
Duplicate.
I'm gonna do it all again,
Duplicate
and
me.
instead of doing add, do subtract also. That way it goes in all 4 directions.
Do we have to do it also like this?
Not per se. If you just have these two, it will also work. I just think it looks nicer if it's like this. Oh, that's not good. Subtract. G. Bloop, bloop, bloop. And then we add these together too. I always cross the lines. That's annoying. Whatever. Add. Holy shit! Wind. Oh! Sorry, the wind just blew my door shut and scared me. Okay.
Oh, there's a ghost.
Yeah, there's a ghost. Clearly.
Oh,
So
The ghost can help him.
the ghost can help us with shader programming. That's true. So these are all the same. The only difference is this is red and added, green and added, red and subtracted, green and subtracted. So red and added just means an X gets added, a Y gets added, X gets subtracted, and a Y gets just subtracted.
So we have to copy it now, the same kind of thing, right?
You can. To be honest, you only kind of need these, but it will just look better. It makes the outlines like a bit thicker, I think, mainly. If we look inside of the scene now, I think it looks good, like with those thick outlines. Why does this not? Oh wait, they're the same color. I forgot I did it with color. Yeah. For the people at home, if you're doing this and you want to like make it further with the normals also, just set these to like normal world vectors. I'm gonna set them all to normal world vectors just to show it.
All of these or some of them?
All of them. Like ideally, what I did in my like full shader, is I just like had one for normal, had one for the colors, and then I just could manually enable and disable them. What the fuck is it doing? Hello?
Oh wow.
No, I'm moving around. That's not good. That's definitely an oopsie. Hang on. Threshold. But it's here.
You have a ghost.
I have a ghost. I'm just gonna put them back to blood sources. Yep, I did nothing.
When you make subtraction, does it matter where?
Oh. Sorry, does it matter where?
Where do you connect
In which
them?
slot?
In which slot?
No, because we use length afterwards.
And then how
we just take the absolute value.
together?
Sorry?
How do you find them all together within each other?
How do you put? It's just all add nodes, add nodes, add nodes, and then I saturate it in the end.
So like all of them have. No, you saturate in the end.
Mm-hmm.
Show it again.
I just saturate in the end. Because like they will either be like 0, 1, 2, 3, or 4 worst case scenario, and 4 will fuck things up. So I saturate it. Saturate is just clamp node between 0 and 1, right? So if we look now, wow, and then we can adjust the alpha. Oh my god! Wow, so cool. All right.
Wait a minute.
I'm waiting a minute. Oh yeah. It will like look very weird in some spots, like here, because of, but that's just because it's a lit shader. Whatever.
Why does this look so sick?
What?
Too much information. Why does this look so much information? Let's see what it does.
Yeah, if you get far into a shader, it just becomes super complicated. That's really when you need the Ctrl-G grouping and stuff. Anyway, so I will do a very simple change. If we only want to see the outlines, so if we only want to make the outlines visible.
Oh, wow, it's working for me.
What?
It's working.
It's working? Why are you upset then?
Hey.
Alright, that's good.
What?
There's a flame. Okay, so we want to make, if you look here, the outline is like layered on top, right? We only want to make the outline visible. If only there was like a simple way to find where the outline was. And it was like 0 to 1 that we just could plug in to the alpha easily. Oh wait, we do. We just plug it in. Wow.
What? I just know. With the saturate node, right?
Yep, you just plug in the saturated node into the alpha, and boom, we have it.
And to the base and to the alpha?
Hmm?
No,
Only the alpha and the base color is wait, what? Show it again.
It's the same. It's the same thing because it's both like black and white.
Also, you discard the alpha.
I just discard all of the black ones. Don't take that out of context, please. All right. And then if we want it exactly like the GIF, all we need to do is add a color.
Oh.
Blah blah blah. Color. Boop boop boop. Add it. Because it's already white, we can very simply just do multiply. Because white is like 1, so if we just multiply it by 1, then it works, right? What we can also do is we can just like plug the color straight in. Maybe that's even better. But it hurts my heart a little. But it also just works. Wow, cool black outline. Alright. Did I fuck something up with the calculation? Some of the edges look weird. Huh. Oh well. Anyway. That's the post-processing effect.
Robert, in your reference, the outline is not shown over the noise. I think the outline is not shown over the noise in your reference.
Oh, I'm pretty sure it's just because I use normals there, and not color. Hang on.
Can you show once more the color, how you edited there? Just. Oh, you just plug it in?
Yeah.
Multiply? Okay.
Because no multiply. I forgot it's not needed. It gets tossed anyway, you know. I don't need to do the extra calculation. But if we go to my answer key, I'm just gonna show how it's done for. All right, so this is basically the exact same as we had before. Well, sorry, this is the exact same as we had before, just slightly nicer. Not a lot, but slightly. I don't know why I put in vector. Oh, okay, now that makes sense.
You shouldn't have the screen outline.
I have a
What if I can screen outline?
what?
I have an outline on my screen.
I also have an outline on my screen. I'm just choosing to ignore it.
Okay.
Yeah.
Oh, yeah.
But it's just because of the way the calculation works. Because it like goes one to the right and it sees like, oh, there's nothing here. That's not the same as what I am, so to speak.
Also, my outline is pretty thin. Like it's like very thin.
Hmm?
My outline is like very thin because your outline is like very thick. Like
Yeah, if you fuck with the threshold. Maybe it's threshold? I'm not sure. I noticed I fucked something up. So we're gonna fix that. If you guys care. What I should have been doing is I should have been making a vector 2 and adding it to that, because it's just because of the way it fucking works. It's very annoying, but technically, because what I think it does is this expects like a vector 2 output, so it just makes it a 1-1 vector 2 for no reason, which is stupid, but whatever. So what I'm doing is I'm going in between all of the split nodes and just adding them like this. So R is X, G is Y. Same thing as before. Stupid mistake. But now I know why the outline was looking weird. Like looking angular. I think that fixed it. Yeah, there we go. Beautiful. Alright. So this is the walkthrough guide of the presentation done. Right now, all I have left is, let me close this. All I have left is a bunch of like exercises where I just show you guys stuff and I want you guys to break it down. If you want to do that, then try. And also just like questions you guys have. So.
1 second, let me put the vector 2 in there.
Yeah, you can, I'll give you some time to put the vector 2 in there.
You sound so angry.
What? I'm not angry. Don't worry about it. I just feel silly. Like, oh yeah, I should have thought of that. Step node.
I'm not sure.
Hmm?
I'm not sure it's correct, but let's see how it.
If it looks fine, then it's probably correct. That's my motto for shaders, which is probably a bad motto to have, but oh well. Anyway, now you can fuck around with all of the little things you guys made, and it looks very weird, and you can get some very silly results. But I like it. Anyway. Whenever you guys are ready to move on.
I'm still
adding the vector 2.
Just does it have the vector 2, but okay, sure. Let's say it's done. Okay, I'm ready.
Let's say it's done. All right. So I probably shouldn't have started with this one, but let's break it down. I'm just gonna point out things, and I want you guys to like think of how they did them. Right? I'm Englishing bad. Hang on. I want you guys to. What?
It happens to all of us.
It happens to all of us.
The English is not English.
All right, I'm just gonna look at things, and I want you guys to think about how they were made, right? So, for example, these trees. What do you notice about them?
They have noise.
No.
No.
They have splatters.
Splatters
They
of
have
color.
different colors. They have gradient from down
Dark green
to
Yes.
up. Yes, and yeah, then they have like some kind of, I don't know, brush strokes, not brush strokes, but they look at those, maybe some
Mhm.
some
So
stuff.
couldn't this be like a gradient?
Yeah, I think it is. It is.
I'm mostly looking for the gradient, indeed. This is a completely unlit texture. How do you guys think they did the gradient?
The gradient?
Mm-hmm.
Like just the gradient. Like they just took and did the gradient.
Sure. There's multiple ways to do it. I know how they did this because I did this. But you can have. You guys remember the XYZ stuff I showed, where it's just like different depending on the position?
Yes.
It's just that. It just depends on the Y position, and that's how it's done. You also have this grass in like little waves. How do you guys think that's done?
Yeah, and also
It's outline plus the color gradient.
Mm-hmm.
The grass, is it like what you mentioned about the vertex shader that you can do like
Yes, the grass is done through vertex shaders. Mm-hmm. The grass is just vertex shaders and also like dependent on where it is. All right, next one, very obvious.
Oh,
it's not obvious.
You have the dark grass, and when you go near it, it's no longer dark.
It's with the dot product, or
No.
I mean, it depends on the
No, but it's not the faces.
It's purely dependent on distance. It just looks how far is the camera away, how far is everything, blah blah blah. It's just that.
It's also the one.
Next one. Oh fuck, Valorant. Yes, I was playing Valorant yesterday, and I was looking at this. Holy moly, it looks good, right?
Yeah.
All right.
Like fluid art.
Yeah, it's fluid. Fluids are very hard, but there's one thing that makes them very easy. Well, very easy. There's one thing that's very obvious in this screenshot. It's this thing right here. Do you guys see it?
The lighting? The specks of light?
It's more like... Okay, so I'm just gonna explain this because I don't think you guys will get it. But this this fluid shader, what it does is it uses like it uses the depth map. So the depth map, I can show it to you guys probably if I can find it. Let me scene depth. Depth. I need to put the alpha to 1. I'm silly. Depth. Depth. This is a bad example. I always fuck up with these. Oh. Okay, whatever. Scene depth is just like it looks how far away the object in the image is, right? And what it does here is it basically looks like, is there something behind it? If so, it does like a certain effects. So this is how it like gets the effects like near the edges, because it sees like, oh, the object behind it is only like a couple centimeters. Blah blah blah. But this is way too complicated, and I shouldn't have put it in here. All right, next one. Water. Water.
A bottle of water.
Water. Water.
Bottle of water.
How do you guys think this is done?
Voronoi or something like that.
Noise.
And then some animation to it, the time thingy,
The time.
and
Yeah.
make it fly.
No, that's not. I think that's rotating. No?
Hang on, I will show you guys the water in a second. I'm starting up the Unity project.
I don't understand.
But the way this works is
It's
very
weird.
it's very weird because it's like properly reflective. Like it takes the colors of what's behind it and stuff.
I don't even get what is it.
So it is literally like water with like realistic reflections.
But are you looking at the water?
Yeah,
This is the horizon.
What?
This
How
is-
do you? How do you
I know. Hang on. Let me find the scene. Underwater. Where is everything? Alright, guys. Wow, look.
Oh,
Oh, that's not what I meant to do.
underwater.
Why does it look so shit now? What is wrong with the lighting? Okay, but so what this does is it takes the colors of what's back of it and it like randomizes the incoming vector a bit with noise.
The characters in the background.
Hang on.
What's with the character? They're sacrificing something. No, I'm not sure.
Come again? I didn't understand.
When you were showing the rock in
Yeah.
the background, there were like a couple of characters, and they look like they're sacrificing someone.
Oh, okay.
What's happening?
You have like the fish swimming shader. I just like
I
put
am
them on the
funny.
random objects
Very good.
for fun. I am very guilty, but this is the effect of that.
You have Cedric's image.
I have not made Cedric swim actually. Fuck. All right.
Cedric's image.
But yeah, let me explain how this works. Basically, you have an incoming vector, and then dependent on some noise, it takes like the color that's like here or here or here, right? It just randomizes the incoming thingy. I don't know if that makes sense. It doesn't matter that much. Next slide. Yup. More Valorant. All right. This is this image. So you have like this tech thing, and if you zoom in, you get these. How would you make this?
Just pixels.
Just pixels?
I mean, what
RGB.
exactly?
Yeah, but it's like no, because you're.
Is it like the
column.
squares? The columns or the squares? I mean, if you rotate Voronoi, it becomes like kind of squares. I don't know. Maybe you just make squares.
Sure.
But maybe you kind of find all the pixels and you assign the RGB to each, like you alternate the columns.
Yes. The big player in this is do you guys know Modulo?
Oh no, no.
Modulo is like it only gives you the rest of when you divide something. Modulo is very good. I like it a lot.
Couldn't you also use like a texture for the lights and then a separate texture for
Yes.
how bright they'd be and then overlay that?
You can absolutely do that, I think. But again, there's like a million different ways to do all of these things. If I go into my What I did a while back, I also made like a CRT shader, and I just made it like a post-processing effect even with like with the modulo and those things we saw before. I think I combined it. Not that. Not that. Where the fuck? Oh! Not this.
Oh my god, what's this thing?
It will come next. That's water.
You're playing a lot with the full screen stuff.
That's not good. I like the full screen stuff. It's cool.
Just
That's with the grayscale?
Huh?
Grayscale full screen shader?
Grayscale full screen.
Yeah, because we just added the. It was like a fog or.
Oh, hang on. You mean this one?
Yeah.
No, this is like an underwater thing. It's just like dependent on the distance and stuff. Okay, whatever. All right, next one. This one is hard because there's a shitload of things in it.
Oh, okay. Tune shader.
Yes, we have the tune outlines.
Yeah, tune outline and
oh my god, there's also like Bloomsy.
bloom. With the stars.
Or not bloom. How do you call the glitchy this amazing red?
Yes, chromatic aberration. Completely right.
Chromatic aberration. Something that you never should be doing for in Sketchfab.
What did you do?
I haven't, but just like they tell us all the time. Never use it.
Okay, outline. Maybe the water, the reflection is like the shadow in this case.
The reflection is the shadow?
Yeah, because it's like a moving line. Like
oh, yeah.
So it's like a moving quote unquote shadow.
I see what you mean.
The water.
Hang on, I can open the project. If I disable. Where is my scenes folder? Is this the one? Yeah, okay. This is super over-engineered. Don't do this. What this shader does is through code I make a texture that it raycasts downward to see how deep it all is below it. Because
like topography?
Huh?
It's like you're doing topography.
Yes, this is like the topography map it makes. And then it then goes like outwards and into the center. But it's super over-engineered and it can be done way simpler, and you guys should do it. But yeah, that's sort of how that water shader works. And I think you have most of it. You also have the sliding thing, right?
I didn't know if it was like a glitch or on purpose.
It was on purpose. I will show you guys why. Cult of the Lamb, because Cult of the Lamb did like CRT did like an April Fool's video. Where is it? Not that. What? All right, hang on. Don't judge my YouTube homepage. Yeah, Mass and Monster do like this shitload of like random effects. This. Okay, hang on. I saw it and I was like, holy shit, I need to remake this. Because they have also the chromatic aberration. And then they have the like little sliding thing. And I thought it was super cool, so I remade it.
Sacred seduction is the one
like a vintage.
Like a old TV.
Yeah. I think it looks really cool, but a lot of shader is just like looking at cool stuff and trying to remake it. Like it's really something you need to start doing. I don't think I have any other ones. Okay. So, question time. What do you guys want me to teach you?
How to survive second year.
Oh my god.
How to get through Game Art 2.
Crash course, please.
Crash course, second year. Hang on, let me go on to. Let me give an opinion of all of the fucking courses. Course overview. IGP. Game art.
You hope that PD4 changed. That's it.
Yes, you hope that PD4 changed. Game art 2 is the most work in semester 3. All of the other ones are fine. Semester 4 is fucked though. Applied games is a shit ton of work. Game design 3 is a shit ton of work, and platform development 4 is a lot of work. And game art 3 is a lot of work.
Oh, okay.
What's in Game Art 2?
What?
What is in Game Art 2?
It's like taking stuff and getting a concept and like doing the entire pipeline of like making, animating, texturing, rendering. If I go to and PBR stuff, so like normal maps, metallic, etc., etc. Semester 3. I did pretty shit, but I still passed, so you guys can definitely pass. I don't want to show this actually. This looks ass. That also looks ass. That also looks ass. Fuck! Alright.
Very fine.
Alright.
Where do you have?
Wow.
Funny.
Okay.
Wow. The texturing is ass. Don't look at it. But yeah. Game Art 2 is not that hard. Just pay attention and do all the stuff. Okay.
And
Any
Game Art 3?
Game Art 3 is shaders. Woo!
Ooh, okay. Like this type of shaders you just taught us,
like,
or hardcore?
complicated.
Hard. Okay.
Like hardcore.
Well, they like show you half of them. They like give you a grass shader that's already decent.
Yeah, if you do like me and you don't know any shaders and you come to the workshops of first years on shader because you don't understand shaders just like me, I survived, but just by the ones that were given to us on class and doing the rest by myself, but not with shader. I just made other things myself to compensate. And usually the exam of Game Art 3 is the same exam as Game Art 1, but with everything you've learned on top. So it's modular modeling. I mean, it was for us modular modeling, a scene, and you either use PBR or baking or shaders or whatever you want. Yes.
The ugly one.
Oh,
Huh?
And hopefully you won't die.
Yeah.
I hope.
This is my game art too. Not the exam, just like a random assignment. My exam looks really bad. But like the grass that I showed before, it's actually not that hard.
How to do the grass?
Huh?
Show us how to do the grass.
Okay, hang on. The thing is, it's just a lot. It's not hard, but it's a lot, right?
Yeah, half of the grass you're being taught in the first lesson.
Yeah, they give you the grass pretty much. The bushes too.
This is grass. Wheat.
Have you ever seen grass? This is...
Here is your grass.
Game fart? Okay.
Yeah, I named it game part because I am an immature child. Please don't follow my example.
Did you hand it in your game first? Imagine like
We didn't need to hand in the Unity project, only like the assets, so I'm fine. Thank God they never asked for it.
Some of my assets are labeled in a very gruesome way.
Yeah, same.
fuck this course.
Fuck this course? Oh my god.
Game fart 1, game fart 2. Brain fart.
Brain fart?
Game fart. Toxic. First subject.
Toxic game fart is game design with Dave.
Oh. Robert, you will have to cut out this part.
I am not editing shit, dude. Don't look at this. This is kind of ass. Windmill. Oh, I accidentally enabled my fucking post-processing filter on this. I tried it. It looked like ass. I'm sorry, guys. Where do I?
Do you have a world that is curved?
What?
Oh no, you have just a big follow view. It looks like you had a spherical world.
Oh, no, the Earth is flat. Everybody knows that. Wow, beautiful. You guys wanted to see the grass?
Yes. I want to see the grass.
Shaders. Grass. All right. It's a lot. Be warned, but it's just not hard. This is the grass. It's not even that much.
It was fun.
I have like a hue shift based on the position. Yeah, this stuff is given to you, I believe, and the wind stuff is given to you. But I just improved it a lot, and I added a lot of different like properties that I shouldn't have. Like too many. Look at all of these fucking things.
Oh my.
Yeah, but I like shaders, so.
If you guys want to see
That's
how
fun.
a scene that has the minimum amount of shaders ever, the first video on my portfolio just put on the chat is using only one shader and some particles, but basically only one shader, which is nice.
Particles are also very easy, and if you combine it with shader, it's usually very good. Whoop, whoop.
Particles and shaders. Okay.
All right.
We'll survive. We will.
Yeah.
We'll fight.
So no specific questions. No cool effects you want me to remake. Come on.
The grass. Oh, we can make with you grass. I was.
Oh no,
curious,
I would
guys.
like to see how you made the old TV glitch.
Oh. Yay! Woohoo!
You're waiting for.
Do you mean the chromatic aberration or like the left to right thing?
And this and that.
No, I mean the top-down screen glitch.
And I was curious in chromatic aberration. You know, the thing we should never be doing.
Why we should?
I don't know. They just always say
Yeah.
like, don't do it for your sketchfab in your.
I think I missed a couple of shaders. So I also did like
Yeah, that one, the Cult of the Lamb
CRT one.
glitch, or
Yeah, Unity is starting up. Settings.
Chromatic aberrations in shader, like manually instead of using.
Yeah, I did them manually because I'm stupid, and I wanted to. So, old TV lamp shader. For chromatic aberration, I think I literally just like took the blue of the pixel to the right or something.
Chromatic aberration.
Yeah.
Achromatic aberration. Aberration.
Ah, like una.
Hello. Why won't it fucking max out? Oh, there we go. Hang on. Distortion speed scanner display. Okay. What the fuck did I do here? Hang on. Okay. We have. What? Oh my goodness.
No cool things today?
Sorry?
No cool things today?
No cool scenes?
Things? We're not gonna see the
glitch or
the glitch?
the chromatic
Or
aberration?
we will.
This is the.
The glitch.
Yes.
The
But
old
Yeah. So many
I-
shaders.
okay, hang on.
Yeah.
I am trying to find the tree in the forest, so to speak. What the fuck did I do? Why is there a modulo here? I didn't even use this. Wait, hang on.
You said you love modulo.
Yes, but I didn't even use it. I don't know why this is here. Hang on. Only this is actually being used. Okay, okay. I cleaned it up slightly. That's good. So okay, we begin with a time node. That makes sense. Modulo. Yup. Comparison, subtract, and multiply. What the fuck was I doing? Oh, okay. These are all like calculations to make it look like slightly to the left or slightly to the right. Like you see the thing?
The bar, yeah.
What I'm essentially doing, I will open Paint again, like the beautiful human being I am.
You're like alternating the.
Yes, I am. What I'm essentially doing is this is like our normal screen. And what I'm doing is I am like through a bunch of maths, I'm like going boop, 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 boop. Like this pixel here is being told, oh, render this pixel here, right? Or take the color from that pixel there. If you get me. Yes?
Yes.
Mm-hmm.
And yeah, then I do it through a bunch of maths that I like automated the process. I'm pretty sure. Oh my god, I have so many shaders. So that's that. So we can ignore this part. And then for the chromatic aberration, oh my god. Yes, I literally like added some vector 2 to it, and I'm like, oh, take the red of the pixel there. So if we have our screen, oh, I can show it in Photoshop with an image actually. Basically, what I'm doing is I have my image, and I am like overlaying. How do I say it? You have like the different RGB channels.
Mm-hmm.
I'm like shifting them slightly. Like I have my reds slightly to the right. I have my blue slightly to the left. Like you can see it here too, especially in like
Okay.
you have like the red sliding more to the right, the blue to the left, and like the green in the middle. I'm pretty sure. I think I can. Oh, yeah! Now you see it, right?
Oh, okay. Yeah.
Holy shit, that looks cool.
That's amazing.
Oh wow! But yeah, you can see like the channels are just split. Like green is in the middle, blue and red above. Okay.
That's trippy.
And you have the scanner displacement, which is the left to right. And the speed, which is yeah. All right. That's a breakdown of the.
That's why you don't eat mushrooms, kids.
That is why I don't need mushroom. True. That you start like seeing triple.
Yeah. I mean, this could be a cool way of making like you eat something.
Yeah, and then you like start.
Seeing things.
Dude, I'm tripping.
For a couple of seconds.
Hello, Giovanni.
Trippy.
They're having a cold here. I ate some mushrooms.
Why is the left one like irregular, but the right one is completely fucked? Let me. That's so weird. Oh, because I did stupid stuff to him with shaders. I forgot. All right. I think that's everything. Any other shaders? I have the CRT one too. Fish.
I think that's what it's called. Dithering.
Dithering? Okay, you guys want to do dithering?
I don't pronounce it. Dithering.
Yeah.
Dithering.
I have yet to do a dithering shader myself, but all right. If you want, dithering's pretty annoying.
I mean,
But-
it's all pretty normal.
No, it's okay. It's okay. It's okay. I will fix it. I think the easiest way to do dithering is like hang on.
With a simple noise?
No.
No?
Okay. I will make something in A-Sprites for demonstration. I need A-Sprites because it's like low poly. So I think the easiest way to do dithering is if you have like, oh fuck. Okay. So you have like all of these, right? Depending on how much you want. I don't know how to explain it properly.
But it's like a gradient?
Yeah, it's kind of like a gradient, but like I've seen people make like a diver map. Like they just have like a texture that's like a regular diver pattern that repeats. So they have a texture that's like a regular diver pattern that repeats, but it's like it's not like black and white. It's like a bunch of like different grays, right?
Gradient
Yes,
gray?
this.
Okay.
All right, so they have this, and they just check the pixel if it's like above that value or below that value, because it like repeats. I don't know if you guys are following like my reasoning.
No.
Okay.
So looking at the squares right now, you know.
The pixel map.
The pixel map, yeah, looks cool.
It does look cool, but it's important because basically what will happen is it will check if the color is like above or below like the value, right?
Mm-hmm.
And what this automatically does, it will just automatically diver if it's like black and white, because the output, if it's like above or below, is black and white, right? Okay, you compare whatever you want to diver to this map, right?
Mm-hmm.
If it's above or below, it will output either like a black or a white, right?
Okay.
Because these are like in between, since they're all like gray, you will automatically like get a dithering effect because of it. Because like, hang on, Bayer matrix apply. Oh my god, this is so much nerd shit. Wow. That's not what I wanted. Dithering. Okay, but image different. Okay. I think this. Yeah, Oberden. Okay, good. So they have like this image that they start out with. They do it black and white, and then they compare like each node if it's like above the threshold of like this matrix.
I mean, it's like a grayscale, and then it's turned into black and white.
Yes.
Okay.
This is it's with like random noise, which looks bad, but then they like add the checker pattern, and then it like makes this effect, right?
So you have the noise pattern, and you mix it with information of the black and white of the picture.
No.
And
Like this is just an example. If you do use noise, it like looks very sloppy. But because they use like a regular pattern, it like makes a lot more sense. Yeah, that's exactly what they're doing. Like, this is only with like two kinds of grays, so it's like very monochrome. But like here they have like a bigger pattern with
The
like
buyer.
more different kinds of grays. So there's like more like, how do you say it?
Information.
More depth, yeah, more information.
Mhm.
And then they color it too. This seems like a pretty decent paper though, even if it's an R. But do you kind of get what I'm trying to nudge towards?
Like still don't get the math behind it, but I kind of get the concept.
Okay, it's more like just a different grays comparing it. Just don't use noise. But I think because of like this pattern that they use for the differing, they automatically like create like a bunch of these like differing effects, so to speak. Yeah, they automatically like create cross-hatching patterns, which is very good. All right.
Okay.
I will put this fucking paper in like general or something. Yeah, but you can read this and like only read the text and ignore the code because I'm pretty sure this is in like R or something. Oh, this is somebody's blog. Yeah.
Yeah, but Aberdeen is a very good example.
Overden is a very good example of a good differing.
Also, the animation here, it was done with the time node. The dithering, and then you would add like
what you can, yeah, you can like move the dithering map if you wanted to. Also depend. I recently saw like a really good dithering shader somebody made. Hang on. This is somebody's grad work. But I really love it. Like it looks really good.
yeah.
So ask this guy for help. He did it in Unreal Engine though. Yeah, he made like the threshold and then he just compares. The reason I'm impressed with him is like if you look around, even though it's a post-processing shader, he like made it so it still moves. But yeah, it's a lot of nerd shit that I am bad at explaining. Okay. But this is like a really good example. I think he just has like a... Does he also have a Bayer matrix somewhere? I'm not sure. But like these like cross-hatching look really weird. So I don't really know what he did. I think he like made different Bayer patterns. Or sorry, different patterns to compare to. I don't know. I'd have to ask him. Point is, looks cool. Whoop, whoop. Oh shit. Anyway. Anything else?
Do you have a question?
No.
No.
Okay. Then I will be ending this session. If you guys have any questions, feel free to ask me always. Okay, that's pretty much it. Thanks for coming. I will put the recording online when I can. Yeah. The monkey is here in the recording apparently. That's good.
I like the monkey.
What?
I like the monkey.
Good, because he's on the entire like 3-hour recording. Alright.
That's cool.
Stop recording.